Hello, class. I'm going to work on the second part of the Zoom video for the statistics course, section 2.2, which covers histograms, frequency polygons, and the ogives. So the first part really stressed the histograms and frequency polygons. This section is going to focus more so on the ogives for the most part because the ogives weren't covered on part one. And so we're going to continue in your workbook, okay? So if we go to our workbook for statistics, the main course, it's page 37, okay? And this is talking about ogives, you see. So the last thing we covered was frequency polygons. Okay, so it says here, so it says here that the ogive, and you can follow along also if you have your workbooks, the ogive is a graph that represents the cumulative frequencies for the classes in a frequency distribution. Okay. The upper class boundaries are represented on the horizontal axis. Okay, so let's keep that in mind. It says, example, construct an ogive to represent the data for the record high temperatures for each of these 50 states. So here you have your class limits, you have your class boundaries, then you have a frequency calculated here, okay? So if I just highlight some of the information they have here, they say that the upper class boundaries are represented on the horizontal axis. So that's why if I look at upper class boundaries, you know, these are um, upper class boundaries. So these are lower class boundaries, upper class boundaries, okay? So these are upper class boundaries here. And also remember from the very first page that we have, so I can find our first page from this section. There was some information there as well about the ogives. If you go back to the first page 34, remember this page 34? And I'm going to just tweak this a little bit, only because I had just put F here. But you can see here now that it says that the ogive as a graph represents the cumulative frequencies for the classes. And so here we can put here CF instead. CF for Y, for cumulative. Cumulative, let's have that one M. Frequencies. Okay. And then it also had said something about that the lines for the ogive begin on the x-axis. So you see it's only anchored only at the front only. An ogive is only anchored at the front, where the frequency polygon has to be anchored on both sides. So those are things to keep track of, because when you do your homework, if you have a multiple choice problem, those are good distractors to give you a choice that looks like an ogive, but what's wrong with it is that it's anchored at both ends. Only the frequency polygons are anchored on both ends. And so this starts off anchored at the front end, and so it starts off with some class boundary, and then 0. Okay, and so just keep that in mind here. Okay, so this was talking about the lines for the ogive begin on the x-axis. Okay, so just keep that in mind. Just wanted to tweak that page there. Okay, and then that's why I'm gonna highlight this first. It's not an upper class boundary, but that's why I would highlight this as well. Sometimes I'll highlight that because it has to be bounded. And so when you bound it at 0, you start off at 0, then it can be bounded using this first lower class boundary. And then these are all going to be included on the x-axis. So these are yellow included on the x-axis for an ogive. Okay, so let's see at the bottom. It says at the bottom, it says find the cumulative frequency for each class. Okay, so they start off here less than 104.5, but then you see they start with 2. And that's why I highlighted the less than here, less than 99.5. That would start off at 0. So remember we talked about on the last lesson kicking it off with 0. Okay, and then we have 2 here. Notice how we have 10. So this is 10 because what they're doing is they're taking this 2 plus this 8, and 2 and 8 is 10. And then look how it goes to 28. So the reason why that's 28 is because they're taking this here, this 10. So let me put a check mark here, and then they must be adding 18, right? Because 10 and 18 give you 28. And then here they have 41. So how are they coming up with that? So they must be taking that 28 plus that 13. 20, 30, 38, 39, 40, 41. Okay. Yeah. And the other was another way is if you have your actual data, then you can also look at all your data, and you would have 50 data pieces, right? 50 states, so 50 temperatures, and you would want to see how many temperatures total are less than 119.5. So you see you would have a lot, you'd have 41. So it's just faster to do this count, right? And also sometimes you don't actually have the data. Sometimes you're only given this, which remember this is called group frequency distribution. So remember there's 3 kinds, right? There's the categorical, which the data is just basically made up of nominal, right? Of just letters, for example, like blood types, for example. And then you have the group frequency distribution, where the data is going to be large, like these are temperatures, and looks like some of them are over 100. See, they're large numbers. Group frequency distributions. This is that. And then there was the third one. Remember, we did that problem about the dogs and the pet shelter, and those data values were uniform. It's a uniform frequency distribution. Okay, and oftentimes the numbers are small, not like these in the hundreds, right? So it could be something maybe under 100, maybe, right, or even smaller than that. But that was a third type. Okay. All right, so here with this 48, this is because they're taking this 41 plus this 7, which is 48. And then here, they're taking that 48 plus this 1 right here, which is 49. And then they're taking this 49 plus 1, which is 50. Okay. And so remember when you do the cumulative frequency and you do this check, remember this value should equal the total amount of data values. Yeah, and remember we said that this was the data was from the record of these high temperatures that were from each of the 50 states. Yeah, so I believe there was 50 data values there, okay? All right. Okay, so that's 37. Okay, let's see what's going on page 38 then. Let's see. Get Okay, so let's see on 38. Okay, so it looks like if you look at these pictures, see, this is what we're leading up to discussing. This is an example of an ogive here. Record high temperature. So it's not a, this is not a histogram. This is not a frequency polygon. This is an ogive. Instead of ogive, ogive, okay? And so let's see what they say at the top. Draw the X and Y axis, label the X axis with the class boundaries. Okay, let's see if they did that. So if I go back to this previous page, remember how I highlighted these here? 99.5 to 104.5. So if you look at your x-axis, let's see, do these look reflective of the CB, the class boundaries? So you see how class boundaries end in 5. So you see how those end in 5? On your paper, you should have your paper there. So let's see. So you see 99.5, 104.5, 109.5, 114.5. Yep, all the way to 134.5. Yeah. Okay. And again, see how this one kicks it off. It's anchored. So remember these ogives, remember it has to be anchored at the front end only. Okay, let's see. So then let's see, what else do they say? So it says, depending on the numbers in the cumulative frequency columns, scales such as 0, 1, 2, 3, or multiples of 5, 10, 15, or multiples of 1,000, 2,000, so on, can be used. Okay, so depending on the numbers of the cumulative frequency columns. Okay, so, but they're telling you do not label the y-axis with the numbers in the cumulative frequency column. So let's see. In this example, a scale of 0, 5, 10, 15 will be used. Okay, so I guess they're just saying they just don't want you to list, like for example, our cumulative frequency, where these numbers 2, 10, 28, 41. So I guess they're saying they don't really want you, they don't want you to just label these based on only these. They don't want that. Okay, so they want you to use some type of multiple. So here they're using multiples of 5. Last time on my examples for the NFL data, I believe I was using multiples of 3, right? 3, 6, 9, 12, 15, and so on. So this is, they're using 5 here. Okay, and you see here cumulative frequency. Yeah, so that was why I had to edit this first page. Remember this first page that we started off? So now the ogive refined that to CF, cumulative frequency for the ogive. Okay, all right, and then so then they put these points in. So let's see where these numbers are coming, these points are coming from. So this is a 2. This is coming because of this. Let's see, this is coming because of this 2 here, and then this is 10, so this needs to reflect 10. That looks about 10. And then we have 28 and 41. So you see that looks like 28 and 41. 48 and 49. Okay. And then the 50. Yeah. Okay. So they're showing you that, and then they're connecting the points. So let's see. So it says step 3, plot the cumulative frequency at each upper class boundary as shown in figure 2-3. Upper boundaries are used since the cumulative frequencies represent the number of data values accumulated up to the upper boundary of each class. Okay. Yeah, and in the past, sometimes you've seen me in the past, sometimes I will highlight this and then this, right? So sometimes I highlight this side and this. This will also work. So I highlight this first lower class boundary and then all of these. So either one that will work, okay? All right, so then at the bottom, starting with the first upper class boundary, which you're saying is the 104.5 at a frequency of 2, connect adjacent points with line segments as shown in figure 2.4. Then extend the graph to the first lower class boundary, which is the 99.5. Talk about this one. On the x-axis, okay? And that's why here I did this, and then I kicked it off, remember, at 0. So that's this point right here. So this point is 99.50. So this is the first lower class boundary, whereas this is the first upper class boundary. Okay, so this point is 104.5, and then that was 2. This one is 109.5, and then looks like it's, oops, it looks like it's 10. Yeah, so 0, 2, and 10. So that's this 0, 2, and then 10. And then we have 28 and 41. So that this would be 114.5, 28, 119.5, that should be 41. So after 10, we had 28 and 41. Then after 41, it's 48, 49, and 50. So then this should be 124.5. After 41, we had 48. So sometimes, let's see if I get a ruler to kind of, that will also help, you know, if I do this. Let's see, because it's supposed to be 40. So see, here's 45. So that might help. So they're saying that's 48. And they're saying this is 41. So there's, if you had to draw lines, and I think we saw that earlier on a page, maybe they would draw a line to that. So maybe if I do something like this, this is supposed to be 41. Kind of helps you get perspective of that highlight that point, because you don't have all those on a graph paper. You'd have all those intersecting lines, so we don't have all those intersecting lines, so this gives you an idea. So then after the 48, we have 49 and 50, so that would be this one here, 49 and then 50. So this is 129.5 and then 49, and then this last one is 134.5 and then 50. Yeah, so that represents this. Okay, and then you saw this here, 134.5. Okay, and just remember to use the cumulative frequency, not just the frequency, but the cumulative frequency. So that's how the ogive's different from the previous two graphs that we did in 2.1, right? The histogram, which used the class boundaries and the frequency, and then the frequency polygon, right, which used the midpoints and then the frequency. So the ogive uses the class boundaries like the histogram does, but then it does make use of the cumulative frequencies, okay? Okay, so then let's see what happens on the next page to see. So on 39, it says that cumulative graphs are used to visually represent how many values are below a certain upper class boundary. So for example, to find out how many record high temperatures are less than 114.5, locate 114.5 degrees on the x-axis Draw a vertical line up until it intersects this graph, crosses over that, then draw a horizontal line at that point to the y-axis to kind of pinpoint what that would be. And that's why that's why I kind of did that earlier, but this is the point 114.5, and now, these are temperatures, so that's why they have degrees. And I think it was, yeah, Fahrenheit. And then they're saying that would have been data value 28. 28. Yeah, so we should see that one of those temperatures here. That would be this one then, see? All right. So that's an ogive then, okay? Again, it's anchored at the front, okay? So if we try an ogive then from our those handouts, remember I had those extra handouts, so we can kind of do one by hand ourselves. Let's see where those extra handouts are at. So I had last time, let's see, looks like these graphs, if you printed those, these were graphs. So like if you want to do your homework, you have the option to print your homework if you want to do it on paper first, so you're not just glued to the computer all the time. You can do that. It just probably takes up quite a bit of paper, but the to do one by hand, this will also help you when you're working. You want to do it on paper first, you sketch it out on paper, and then you go to your computer and work it, so you have an idea where you're going with it on paper first. So I had made this one generically an ogive. So the first lower class boundary used to anchor the ogive, and then I have here then the upper class boundaries. So you just bound the first one with 0, start off at 0. So it says on computers, now we have the new enhanced version of Connect Math, but in the past we said that on computers you want to use your cursor, your mouse, and connect from left to right, left to right. So we're talking about when you're drawing these line segments, you're drawing these line segments, you have to pick up your mouse and your line segment and connect from here to here. So you would have to, that's why you kind of do it on paper first, so you have a visual idea of where you're going, and then you have to recreate this on the computer. You're not going to just start like in the middle here, right? You've got to start back here that it's anchored, okay? So that's what this is talking about, connect from left to right. Use the lower class boundary to anchor the graph only at the beginning of the graph. And this got caught off, but it says don't label. So that's probably what that comment was saying, like not to label the cumulative frequency, the y-axis. Don't label it like just with your cumulative frequencies. Okay, so this got caught off. Let's just see. Cumulative frequencies there. Yeah, so I did increments of 5. They were talking about 5, 10, 15, 20. I did that. And you see on my lines how I did 1, 2, 3, 4, 5. Even, oh, here I did 3s. 1, 2, 3, or tick mark, 1, 2, 3. So I have these 3 boxes. So I did this in increments of 3 and this in increments of 5. Okay. So, but it's still consistent. If I'm going to use 3 here, I use 3 all the way across. If I'm going to use 5 here, up and down vertically, I use 5 consistently. All right. So then, so I'm going to keep track of that. And then I do have this sheet here for ogives. I have here for ogives. See how I have, like, you would put your class boundaries and then your frequencies and then whatever it's less than, and this would be to kick it off at 0. So I do have that there to help generically when you're going to have a couple ogives on your homework, so you can make use of this sheet for those 2 problems. So you'd have your skeleton, or you can make your own table on your paper. Okay, so now I need to find, last time when we were working on that NFL problem. Where is that data at? Let's see. Okay, so here's an example. Remember we're working on that NFL problem. Remember that NFL problem? So we had salaries in millions of dollars for 31 NFL teams for specific season are given in this frequency distribution. So you see how we already have the class limits and the frequencies. We have the midpoints, and then we have the class boundaries. And I have this as usage for ogives. So let's see. So actually, if you wanted to save time, we could use this here. And but the thing is, I don't have enough room unless I white that out. I need to do the cumulative frequencies. So I think that's why I had this generic. See how I have this cumulative frequencies to do that part. Yeah, so that's fine. So I'll go ahead and do it here since that was what that sheet was intended for. But to save time, technically, I could, white this out and make use of this and then put cumulative frequencies here. And I would just kick it off with a 0 first up here and work downwards. But that's fine. So let's see. So if I put CB stands for class boundaries. So I'm going to record these, okay? I'm going to record these class boundaries from the NFL teams right here on this sheet. Let me do that. So I'm going to say record NFL salaries class boundaries here. Okay, so I have 39.85 to 42.85, 42.85 to 45.85, 45.85 to 48.85. And just to remind you, this is allowed. This is okay here. See how this matches this? See how this matches that? That is allowed because these are class boundaries. Where that cannot happen is in class limits. Class limits, see, this needs to be a increase of some form of 1. So like a plus, in this case, plus 0.01. So here it has to be an increase of either +1, plus 0.1, plus 0.01, plus 0.001. So here that sum has to match the data value for that here. So this is just to keep that in mind. Okay, so then this is, oops, 48.85, 51.85, 51.85 to 54.85, 54.85 to 57.85. Okay, and then I'm also going to write down these frequencies. So the frequencies, I'm grabbing them from here. Remember these NFL, this was a total of 31. Remember 31 NFL teams. Okay, so let me write those down. This is a summation. This is a sigma, which is a Greek letter of the alphabet, and it means a summation, which means when you add all these up, summation, F for frequency, you're supposed to get a total of 31. Okay. All right. So then I don't think I need this sheet anymore. I think that'll do that. Okay. So then now let's go to for the ogive, let's go to make our cumulative frequencies. So you see how I have less than? So this is where I'll do kind of something like this. So less than these, and then I'll highlight these if I do something similar. So I kick it off with less than 39.85. And with this NFL data, we never had the original data. We were given the group frequency distribution. We were just given the class limits for this problem, okay? And sometimes that can happen. You don't always have the data. Sometimes they just give you already. The only time, the time when they would give you the class data, the time when they would give you the data would be when they would want you to create it from scratch, create the uh, group frequency distribution from scratch, then they have to give you the data. But otherwise, if they don't give you the data, it's probably because they already just gave you the group frequency distributions. They already gave you the class boundaries and the frequencies, okay? Okay, so then here, when I fill this in, less than 39.5, less than 42.85, 45.85. So I'm writing these in. Okay, then we start doing our group frequency distribution. So remember, we'll kick it off here at 0, that this is where it's going to be bounded on our graph, bounded 39.85 comma 0, because it has to be anchored. The ogives have to be anchored at the front. And then when I have here the 42.85, this will be 2. And then next, so I'm going to put a check mark. And then now this is going to be this value, which is the 2 plus this 2 here, which gives me a total of 4. And then come over here, so then I have 4 plus this is 5, which is 9. And then I have 9 plus this value here, which is 5. 9, 10, 13, was that 14 class? Okay. All right. And then come back over here. 14 plus 12. So that's 26 when I add 14 and 12. And then 26 plus 5. Oh, good. And that gives me 31. Good. So see this total right here should equal the data total. Remember we had 31 NFL teams, so you should check for that. You do your homework, that should match that. Okay, so then now we can just start. This is related to what's coming up in a future page, but for now we have everything we need to make this ogive for this NFL team. So now let's go to this sheet, this ogive, and this is for the NFL salaries. NFL salaries. Okay, so then now at the bottom, right here, the first lower class boundary, that's going to be what I have here highlighted, 39.85. Then the second one's 42.85. So this is going to be 39.85. That's bounded at 0. So on the computer, they're not going to want you to label this on the computer, but that's just for you doing on paper first to give you an idea. That's this point here. And then the next we have 42.85. And remember that was 2. See? So 42.85 and 2. So this is 39.85 with 0. Or I can look here too. 39.850, 42.852. So 1, 2. And then you get your ruler. If you're doing it by hand first, you get your ruler, connect that on paper, and then this is what you're going to have to recreate. Once you do it on paper, if you're a visual learner like I am, then you do it on paper first, and then you go to the computer and you know what you want. And you do it on paper first, you just double check everything looks good, and you recreate that on the computer. Okay, after 42.85, you have 45.85. And that would be the 4. So that's right here. And so when you make your line segments, but when you use your mouse, they're saying it's probably best to connect from left to right. You can experiment with that. If you have an idea where you're going, technically you could go from right to left or from left to right. You have an idea already of where you're going first, right? It also depends on your mouse. Sometimes you have to clean your mouse. How clean is your mouse when you're doing this? Okay. All right. And then after that, 45.85. Then we have 48.85. So remember these are going to be, remember you think about class widths, they increase by 3. So you see all these are going to increase by 3. See, 3 more, 3 more, 3 more. Yeah. Okay, at least those are the class boundaries increasing by 3. And then after 4, we're up to 9. See 9? So 5 and 9 is right here. And then 3 more. And then that's going to be, see, 14. Okay, and then after 51.85, we have 54.85. And that would be 26. Oops, it looks like I was a little bit off. 51.85. 51.85 was actually right here. Okay, so should be. So those kind of things, you just be careful when you're working on your computer. I have to white that out. Okay, and then after 51.85, you have 54.85 and then 26. So I'm going to keep my finger on that line so I won't make the same mistake. Off by a line segment there. Okay, and then after 54.85, we have 57.85 and 31. Okay, so there's your idea for your graph there. So you've got, it's only anchored at the front. You kick it off with 0, remember? And then as a check, when you're done, this last one should reflect the total of your data values. The 31 just reflect that, okay? So you could make a note of that there. So I have the last y coordinate, the last y coordinate equals the total data amount. So in our case, we had 31 NFL teams. So it was the salaries and millions of dollars for 31 NFL teams for a specific season. So 31 NFL teams salaries. I guess we could do that then. Okay. Okay. All right. Okay, that's good then. So, and then what you can also do here, remember cumulative frequency, that's CF is what I had on that other page. CF, cumulative frequency. Okay. All right. So that way we practice one on by hand. Okay. So now let's see. Now let's go back to let's go back to the other page. Let's see. Let's see. So let me fix this real quick on my paper. It should be a 10 here on my paper. Okay. All right. Let's see. Okay, I think we're going to go to we had just finished on back on that other problem that we were working with because we jumped to the NFL team data for the OJI. We go back to that temperature problem. I think we had finished 38, right? So now I think we're on, yeah, and then we had done part of 39. Yeah, so we're on 39 now. Let's go back to 39. Yeah, we were on 39. Okay. Okay, so now let's see what's next. What's going to happen next? It says that if proportions, let me just highlight that. So this is something a little different. If proportions are used instead of frequencies, the graphs are called relative frequency graphs. Okay, so remember that. So we have something called relative frequency graphs. That's if proportions are used instead of frequencies. Okay, so relative frequency graphs are used when the proportion of data values that fall into a given class is more important than the actual number of data values that fall into that class. Okay. Let me just say, I thought I had a page to emphasize that. Let's see, hold that thought. I might have to get my ebook out. Let me see, I thought I had it here. Unfortunately, I don't think I do. Okay, if you can just bear with me. Sorry about that. Let me see. Let me get my textbook out. Okay, we get my textbook out. And let me see. Let me go to 2.2. Sorry, I don't have this out already. Let's see. Too many things to remember before I do a recording. So sometimes it's simply not enough to get your workbook pages out. Sorry. Yes, yes. Okay. Let me just, this is in our, you have your ebook too. If you wanted to go to your ebook, this is where this is coming from. And it looks like this is on page 61. And when I've asked you to read, you always read in statistics, you always want to read your ebook as well. And this is on page 61 of 2.2. And this is, where some of your workbook information is coming from, but we can't put everything in there. but this would be helpful to go to this example. So we were talking about relative frequency graphs, and we said that graphs of relative frequencies instead of frequencies are used when the proportion of data values that fall into a given class is more important than the actual number of data values that fall into that class. Okay, so I want to give you an example of that. Here's a very good example of that. For example, if you, and again, it's on page 61, and again, this is section 2.2, right? So this is page 61, and this is section 2.2. And it says, for example, if you wanted to compare the age distribution of adults in Philadelphia, Pennsylvania, with the age distribution of adults of Erie, Pennsylvania. So they're both in Pennsylvania, right? Cities in Pennsylvania. You would use relative frequency distributions. Okay, so why? The reason, so we have an idea over here. It said something about when the proportion of data values fall into a given class is more important than the actual number of data values. Okay, so this is related to that. The reason is that since the population of Philadelphia, look at this. This is like in the millions, right? 1,526,006. And then look at the population of Erie compared to the population of Philadelphia. Look at that. It's only 101,786 compared to this city having a million. Okay. So since the population of Philadelphia so much larger than the population of Erie, if you were to use like those bars, vertical bars, the bars usually the bars using the actual data values of Philadelphia would be much taller than those for the same classes of Erie. Okay, and so this is why it's helpful to have these relative frequency graphs. That's an example. So now here they're showing you how to do that. To convert a frequency into a proportion or relative frequency, and we'll see if they have that on our page. Let's see. Let me see. Let me just look at the page and see. I don't think I don't think they write it out, but it looks like they do the math. So we might want to write this down too. It does tell you here what to do. Divide the frequency for each class by the total of the frequencies. Okay. So I think I'm going to write that down. And let me see. I also want to check my little paper here. Let's see. I had the one where I had the calculations. Let's see. This one, let me see if I have that written on this one. I think I might have it written here. Relative frequency. Yes, I think I have that here. I do have it on this sheet here, see? So there's not a need for me to write it here because I do have it here. So again, the book said to convert a frequency into proportion or to convert it into a relative frequency. Relative frequency, it says divide the frequency for each class by the total frequencies, which is their number of observations, to get the relative frequency. Okay, so I do have that there. So I'm not going to write that again. I do have it on this sheet there. But I could, though, put that example about I could though put in, so if you want to pause it, you can pause it and write that down because I already have that there. You can do that. But I'm going to come over here and put that example here. It says, when would we use this? So they have, let me put example. I'm going to say to compare the age of distribution of adults in Philadelphia, Pennsylvania, with a population of 1,526,006. So I put to compare the age of distribution of adults in Philadelphia with the population of this and with the other city was Erie, also in Pennsylvania. And that one had with a population of 101,786. And I'm going to say we're using the bars for, like the book says, actual data values would create a much taller bar for that first city, right? For Philadelphia. Okay, so that gives you an idea then of when that would happen, okay? Okay, so then again, if you wanted to pause it now, you could to write that down. If you haven't written that down yet, you could pause it and do that. But okay, so I'm going to continue now. So then let's see. So now it says here, they have an example. They want you to construct a histogram and a frequency polygon and an ogive, but this time you're using relative frequencies for the distribution shown here of the miles that 20 randomly selected runners ran during a given week. Okay, so I'm sure you have an example of that in your ebook. If you go through the reading, and just trying to see if I have more detail than that, but apparently you have uh, class boundaries and a frequency, and this is not the temperatures anymore, but this is a total of 20. It should be a total of 20. So if I were to add these numbers up, so that's 9 and 10, 15, 16, 17, 8. Yeah, so see there's a total here. Summation of F. There's a total of 20 here. So we've got 20 randomly selected runners during a week, ran during a given week. Okay, so on your homework, you will have some problems where they want you to construct a histogram, frequency polygon ogive, but they want you to use the relative frequencies. So remember what you're going to have to do for the relative frequencies. You're going to have to do this, and I don't know if you want to write relative, how to calculate that here, or if you printed this paper, you do have to know that you're going to divide the frequency for each class by the total frequency. Okay, you will have to do that. And then just remember when you make a histogram, you're using class boundaries when you make a frequency polygon, remember you have to find the midpoint. So you'd have to add these up and divide by 2 and use your parentheses on your calculator. So remember that when you do your midpoints, you'd have to do parentheses 5.5 plus 10.5 parentheses divided by 2, and that's how you would get a midpoint. And you need that for the frequency polygons, okay? And then the ogives again use the class boundaries just like we did a while ago, but this time you would be using the relative frequencies here. So on your homework, I saw a couple problems like that where they want you to use relative frequencies, um, and not the frequencies, but they'll tell you know when to do that. They will tell you just like they did here. They want you to use relative frequencies, not the frequencies. So then you'll have to know how to do that. So they have. We're going to just look at we're not going to do another one of those by hand for that. There is one more graph that's related to an ogive. So we will go ahead and complete that one towards the end of this lecture. So there is one more graph here for that. But before we do that, let's go through your workbook and let's look at them do this. So if you look at 40, page 40, here's the same data, well, class boundaries at least, and then the frequency. See about those runners, okay? And then here they're doing the relative frequency. Okay, so again, I could write that here. Again, what they're doing, let me get that sheet out. What they're doing to get this relative frequency is they are dividing the frequency, which is F, for each class. And it could be like class limit or class boundary, like in this case, we have a class boundary, but for each class by the total frequency, okay, which is the number of observations or like data values. Okay, so that's what they're doing here. So you'll notice here they're doing 1 divided by 20. See, 2 divided by 20. See that? 3 divided by 20. 5 divided by 20. 4 divided by 20. 3 divided by 20, 2 divided by 20, okay? And then let's see what, does it, do they have to round off on their own or does it terminating? Let's see, when I do these, 1 divided by 20 is 0.05. 2 divided by 20 is 0.1. So 0.1 is the same as 0.10 or 0.10. 3 divided by 20. 5 divided by 20. 4 divided by 20, 3 divided by 20, 2 divided by 20. So we didn't have to round off on these. Maybe there might be a time when you'd have to round off, but these seem to all terminate. What we are noticing, and see, I will make a comment about this though. What I will comment on, 2 things. Okay, so see how they have summation of RF, that's for relative frequency. So see how when you add these up, you want this to happen. This is characteristic that the total is equal to 1. And I could put a formula for this when you calculate the relative frequency, which is called RF. We could say here RF is equal to F divided by the summation of F. So that's kind of true. So 1 divided by 20 2 divided by 20. So remember, this is frequency, this is your F. So F divided by the summation of F, which was 20. So that's true. And I want you to notice here on the class boundaries, I want you to notice is that the class boundaries are in the tenths place value. So you see how these are all the tenths place value? And notice these are all 1 decimal place beyond. These are going to be in the hundredths place value. So notice how the RF for relative frequencies are in the hundredths place value. So like basically 1 decimal place beyond how class boundaries are presented. Yeah, so that's probably going to be a pattern. That's probably going to be a pattern because maybe you might have where you have a whole bunch of decimal places and then you will have to round it off. If that ever happens, what do you round off to? I would practice that. So if this is in the tens, then if you have to round these off to 1 decimal place beyond. So round that off to the hundreds. So these are all in the tenths here, right? Whereas these are in the hundreds, okay? And then your check is that you want this to equal 1. This is important here that you want this total here to be 1, okay? Now, the reason why they have the class midpoints is because they wanted you to make the histogram and the frequency polygon using relative frequency. So that's why they're setting that up for. So remember I did that on the calculator earlier. This is 8 because they're doing 5.5 plus 10.5 and then they're dividing that by 2. So remember I showed you that. And so yeah, I remember on a test you would always show your work like for the first row, but then thereafter you can use after you do like the first 2, right? You would do the second one, you wouldn't have to show this. You doing your calculator divide by 2, but then you see a pattern, right? They're using the class with pattern, and you can get the rest of these. So this looks like it's 8, 9, 10, 11, 12, 13. It looks like this is increasing by 5. Yeah, and if you think about the class width here, you subtract 10.5 minus 5.5, it does give you a class width of 5. So just, you know, keep that in mind. Those are all helpful, right? Keep that in mind, okay? All right, so then let's just look, we're not going to do one by hand, but we're going to look at their pictures. Let's see what the workbook did. Use the class boundaries, remember, and the relative frequency. So not the frequencies like we did on the other lecture, the first 2.1 part 1, but relative frequencies. So you know here are their class boundaries down here. So you see these class boundaries. These are these. See these? 5.5 to 10.5, 10.5 to 15.5. See that? And then these here are not the frequencies, but they said this is important. They said they want you to use class boundaries and the relative frequencies. Remember they told you they wanted you to make a histogram, and then we're going to make a frequency polygon, but we're going to be using the relative frequencies. So you'll see here that this is reflecting 0.05 right here. This height here is reflecting the 0.05. This height here is reflecting the 0.10. This is reflecting the 0.15. This is reflecting the 0.25. This is reflecting the 0.20. This is reflecting the 0.15. This is reflecting the 0.10 on that. So that looks about right, right? And this one almost looks, I think this one kind of looks symmetric. If I had to say, is this more right, left skewed, right skewed, or symmetric? I think I would say this one looks pretty symmetric because you see here's your peak. And you see both of these have 3 columns. See how the data tapers off? And if I just, let me just do the sum. Let me just see what the sum is. If I add this plus this plus this, 0.5, 0.05, whoops. You do that again. 0.05 plus 0.1 plus 0.5. Let me do the other side. Let me add the other side. 0.2 plus 0.15 plus zero point 0.1. It's not much off. 0.45, 0.65. So it's not much off. It's not really much off. I think I would feel comfortable saying that this kind of looks I think I could say this could pass for bell shape. Because it's not off by much. So and then you have 3 columns on this side tapering off and 3 columns on that side. And somewhere you have a sheet over here. Of course, on page 42, remember the sheet? This is actually perfect, right? Perfect bell shape here. But if you look at the right skewed and the left skewed, you can see how, you know, right skewed, so you have 1, 2, 3, 4, 5, tapers off with 5 columns as opposed to 2. See that drastic? And then over here, left skewed, 1, 2, 3, 4, 5. So it looks like 7. 1, 2, 3, 4, 5, 6. This is like 7 and only 1. So definitely left skewed. See that? But I would say when it's so close, 3 and 3, and then you saw the difference when I was adding them up on both sides. And I'll show that here. The total, if I add up, that total was 0.65. Where's this total here? It's not really off by too much. See, so I think that would pass for bell shape. Okay, all right. So then this is as far as data distribution. Yeah, because on your final exam, usually we do put a problem like that on the final where we want you to comment on the data's distribution. And although you have all these scenarios, you know, on the final, we would keep it down, narrow it down to right skewed, left skewed, or bell shape. We would keep it down to those 3 basic ones, even though you have all these different shapes. It's just rare for the other ones to show up often. The one that would show up the next, the 4th most common would be the Pareto chart. And let me see if I can put any more comments on that one since I have that up. Let me see, let me look at my notes. So I do have notes. So here I have reverse J shape. Yeah, so I have this comment, reverse J shape, which, you know, they mean like reverse J shape. Whereas this one is J shaped, is what they mean. Think of that look. And then Pareto, this is a Pareto. They have categories on the x-axis. Yet they have, let me add the word qualitative qualitative, like instead of numbers, they might have qualitative categories. And I also have here, they are also arranged, the bars. These bars are, notice how they are arranged from high to low frequencies. High to low frequencies. Okay, those are characteristics about a Pareto's. The other thing I have here is to note on the left skewed, remember left skewed could be also negatively, remember? Whereas right tail could be positively. The other thing I was going to say is that this Pareto, we're going to see more about that in the next section 2.3. I'll talk about Pareto's more, and this is in section 2.3 also. You'll get more of that. Just give you a heads up on that. Okay, and then also had a comment, let's see, on the bell-shaped. Let's see, let me go back to this. I also had a comment about the tail. Here, this would be considered the tail. Here, this would be considered the tail. Okay. More so than this being a tail, right? Usually the tails are on the end, but this wouldn't be considered a tail only because this is lower. So just to know, sometimes they call this like a tail. It's also, let's see. And again, this is this one we say data tapers off more so on right side of the peak. Whereas over here, we say data tapers off more so on left side of the peak. Okay. Okay, yeah, so those were notes that I had there for that on that I want to put since we were talking about the distribution of the data. So write that down. Okay, let's see. Then we're going to look at the bottom of page 40. So if you're not done writing that down, you can always pause it and then start it when you're done. But I'm going to go now to go back to page 40. Oops, wait, sorry. I think I was going to put one more adjective up here. Sorry. Back to page 42. Sorry, I was going to put up here adjective for this symmetric. Bell shape. Okay. Okay, so write that down, and now let's go back to the page 40. Yeah, so here, this is a frequency polygon, and notice how we're not just using the frequencies that we were told to create a frequency polygon using the relative frequency. So you want to pay attention to your reading on your problems. And if it tells you that they want you to make a frequency polygon and they want you to use the relative frequencies, then you have to follow their directions. If they don't say anything about relative frequencies, then that means you're just using the frequencies, okay? So here, um, remember that these frequency polygons, remember these are anchored on both sides Okay, so you see these are anchored on both sides. Okay. And if I look at my class width here and I do 13 minus 8, which I believe is 5, right? 13. So here to get this value here, this is going to be 8 minus 5, which it looks like that's going to be 3. Looks like this is going to, so this is going to be 3, 0. Whereas over here, this is going to be 38 plus 3, which is 41. So this would be 41, 0. So just keep that in mind. And it's anchored on both ends. And these are, again, this is a frequency polygon. So remember, these are midpoints. These are midpoints, the midpoints. Okay. So remember, those are these right here. See these midpoints? Okay. So for 8, it's 8 associated with 1. So right here, oh, excuse me. No, not 1, sorry. Remember we said not the frequencies. They said use the relative frequencies. Yeah. So because they said use the relative frequencies, be careful. It's 8 associated with 0.05. So this is 8 associated with 0.05. This is going to be 13 associated with 0.1 or 0.10. This is going to be 18 associated with 0.15. This is going to be 23 associated with 0.25. This is 28 associated with 0.20. This is 33 associated with, let's see, looks like 0.15. And then this is 38 associated with 0.10. And then this is anchored 41 associated with 0, anchored at the bottom. Okay. Okay, so hopefully you can, we're using the relative frequencies and the class midpoints. So you maybe want to write that down. We're using midpoints and the relative frequencies. Whereas at the top over here we were using, for the histogram, the class boundaries and the relative frequencies. Okay. Okay. All right. So then what else is next? Let's see. So I think there's an ogive coming up, right? Next, let's see how they made the ogive on page 41. Yeah, and then the last page of 2.2 was 42, which we already discussed that. Okay, so we're coming close to the end. So we're going to discuss this 41, and then I think we're going to, then I think we'll be able to make that last graph by hand. So we had that last graph that if you did that printout, we're going to do something with this graph here. So that must be related to this sheet here. Let's see. So, okay, let's see. Ogives, let's see what this is. Ogives use upper class boundaries and cumulative cumulative frequencies of the classes. Okay. All right. So let's see. Yeah. So if I kind of do my highlights, remember, if I highlight this, and that looks like that's here, right? If I compare those numbers. So yeah, those are your class boundaries. And then cumulative frequencies of the classes. So we're still talking about those runners. We're talking about the runners here. Okay. And let's see, they do bound it. Ogives are anchored at the front only. Okay. And so this, they have it at 5.50. So you have to kick that off with a 0. So they use the class boundaries and cumulative frequencies of the classes. Okay. So let's take a look what they have here. Let's see. Now, I can tell, like I'm looking at the graph to see what they were using here. See how it says cumulative relative frequency? And see how this goes up to 1? Okay. So you see there, you can see they're using this here. See how this goes up to 1? Okay. And then they have cumulative relative frequency. So see how they're getting this? See 1 divided by 20? So they're doing 1 divided by 20. 3 divided by 20. See? 6 divided by 20. 11 divided. So yeah, so they're doing this. Let me go back and write that down. They're dividing. Remember what I said here? They're dividing. What they're doing is they're dividing the cumulative frequency. So let's just put this together. When we're doing this other sheet over here, remember we just did this on page 40. This is page 40. Here they were dividing the frequency for each class by the total frequency. Okay. All right. So here what they're doing is they are dividing the cumulative frequency for each class. So let me write that down. By the total frequency, which in our case was a summation of F. Let me make a better summation. Looks funny. Summation of F. I'm trying to recreate this. Equals 20. Yeah, so that's where they're getting that from. So they're taking the cumulative frequencies and dividing it by 20, and they're saying it's a cumulative relative frequencies. Okay, and again, if you look at let's see if I had to round any. Let's just see. 1 divided by 20, that terminated. 3 divided by 20, that terminated. 6 divided by 20 terminated. They just added a 0 there. 11 divided by 20. Looks like they're all going to terminate. 15 divided by 20. 18 divided by 20. Yeah, 20 divided by 20. So they all terminated, but like what if they had a long string of decimals? Then what do you round to? So again, on the rounding, I would say that that these, just like I put on the other one, these class boundaries are in the tenths place value. So over here, these cumulative, they abbreviate it, cumulative relative, so they abbreviate it, cumulative relative frequencies are in the hundredths place. And that's because it's why? It's because it's one decimal place beyond. How the class boundaries are presented. Yeah, so if this hadn't been in the tens, let's say this had been in the hundreds, if this had been the hundreds, then this would have been in the thousands, would be kind of the idea. If you yeah, when you set those up, just to keep that in mind, something to keep in mind, okay? We'll use that. And we might get to see that on the next problem. We'll have to look and see on the NFL, when we do the NFL data on that. Okay, and let's see, I want to go back and label. I think before I do the labeling though, I wanted to go back and go to we didn't talk about this um, figure here. Did that come from the previous page? Let's see, on the previous page, on page 40, all we had was the frequency, right? And then the relative frequency, and then the midpoints. Yeah, so this is a new column. We should go back and see how did they come up with that. So that's a cumulative frequency. So let's see. So we would say here like it kicks off at 0, and that's where this comes in, 5.50, and that's this, right? Bounded. And then that means this next point here is 10.51, or let's see. Oh no, not 1. Yeah, because look how small this is. No, it's 10.5, and then 0.05. Okay, 0.05. Okay. So I don't know, maybe I can put also a 0 here so we'll remember that. But this is 10.5.05. Mm-hmm. Yeah, and that's because when I go to this last one way over here is going to be 40.5, and then that's 1. And that's what should happen on these. This is when you have a cumulative relative frequency, that should happen on those. So notice on the previous one, on the side here, on page 40, remember these were relative frequencies? Okay, but this one now, they're going to see cumulative, and it's an ogive, and they're using a cumulative relative frequency here on this one, okay? And okay, so we still need to finish this though. So that's how they're getting these data values. So let me can finish this here. So this would be what class? 15.5 and then 0.15, right? And then this is 20.5 and then 0.30. So you see where your teacher's getting that from, going down the list here. And then 0.55, 0.75, 0.90, and then 1. See that? So that's where these are coming. So this is 25.5 and then 0.55, 30.5, 0.75, 35.5, 0.90, and then 40.5 and then 1. That's where that's coming from. Okay. And these are an ogive where they're using the cumulative relative frequencies. Okay. And then let's go back to justify that we have to justify this column, right? Because this column we said was not on the previous page 40. So they're doing, because you need this column, right? You need to come with this column because that's what they're using here. See, 1 divided by 20, 3 divided by 20. So they use this cumulative. See, cumulative. They didn't use frequency. They use cumulative relative frequency. This column divided by that. So let's verify how this is coming about. So then we're adding this cumulative frequency. This is 1, and then this is 3. Why is that 3? Because this is 1 plus 2 is 3, and then this is 6. Why is that 6? Let me put checks on that. That's because it's 3 plus 3, and 3 plus 3 is 6. And then 6 plus 5 is 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 plus 3, oh, excuse me, 18 plus 2 is 20. Okay. All right. So ogives use upper class boundaries and cumulative frequencies of the class. Okay. All right. So I think then on the last thing we're going to do is I think that's what that last graph was for. We're going to demonstrate this. So see how I have here on this graph. It says relative frequency graph, OGI. That's the last graph you have. Use upper class boundaries and the cumulative relative frequencies, just like they say here. And I have here cumulative relative frequency. See how I took it up to 1 like they did here? So, and here where they were doing increments of 20s, point like 20, 40, 60, 80 increments of 0.20. Here I was using like nickels, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 increments of like 5 cents a nickel's worth, all the way to I got to 1. Okay, so it gives you an idea of that. Okay, so let's see. So, and this is going to be for the NFL data. So let's see. Let's go back to, where's that table that we had here? Let me see. Okay, at this one. This is what I'm using. Let's see. Okay, so I think what I'm going to do, I'm going to be consistent with what the book was using. Let's see, relative frequency. Go back to that sheet. Yeah, see how they have a column for cumulative relative frequency, and then they have frequency. So yeah, I think I'm not gonna make use of this column relative frequency. I think I'm gonna just do what they did in the book. there's always a couple of ways to do things. Maybe one's more accurate than the other, but uh, I'll just go with what the book is saying, and I'm going to follow their lead on that instead of doing the relative frequencies and then adding those up and doing a cumulative relative frequency. What I'll do is I'll use what the book was doing here. So they're taking uh, the cumulative frequency and then the cumulative relative frequency. So let's see, do I have the cumulative frequency? I do have that here, right? Yeah, here's the frequency, here's the cumulative relative frequency. Okay, so then here's your cumulative relative frequency. Yeah, let's do that. So what we'll do now is, and how they're saying, divide the frequency for each class. Okay, so what I'm going to do here is I'm going to divide, guess what I'll put it, how did I calculate this? So we did this, we used this earlier for those other two problems here. See, we used those for these problems is what we were dividing by. Yeah, but this one we're gonna, that was what this definition was for. But up here I'll write down this, what I have here. So to calculate this, we're going to be dividing the cumulative frequency for each class by the total frequency. So summation of F equals, and for this one, remember it was 31. There was 31 NFL teams with their still salaries, remember? Okay, so let's show that then. And also notice as far as place value goes, in case it doesn't terminate, see how these are in the hundreds place? See how here the class boundaries are in the hundreds place value. So that means over here, in the cumulative relative frequencies, let's go ahead and round these off to the thousands then. If we're going to be, these are hundreds, so then these will be thousands. And then at the end, the total should equal 1 when we're done. So let's see if that happens. See if we get a 1 here when we're done, okay? All right, so let's see. Got that? Okay, so now you can do a pause and write that down. Otherwise, let me just do this. Okay, so here we go. So let's see. So let's think about what we're doing here. Remember how we took the cumulative frequency? Here we did 1 divided by 20. Okay, so for us, I'm going to highlight, we're looking, so we're looking at this cumulative frequency, and then we're going to divide it by 31, okay? So if I start with this one, this is 2 divided by 31. Oh wow, look how long that is already. So you see it. So I'm going to approximately, so equal. So here it's 0.0645161. And you may not want to write all of those digits, but if I round to the nearest thousands, tens, hundreds, thousands, and look at the number to the right, is that 5 or more? Yes. So you're going to add 1 to that. So this looks like it's 0.065. Okay. And then I have 4 divided by 31. 4 divided by 31 is 0.12903. And if I round that, I'm not going to put all those decimals, but if I round to nearest thousands, tens, hundreds, thousands, look at the neighbors at 5 or more. No. So that's about 0.129. Okay. Okay. Let's see. Then we have 9 divided by 31. So 9 divided by 31 is 0.2903 and so on and so on. So tens, hundreds, thousands. Okay. So this is approximately 0.290. Okay, then I'm going to do 14 divided by 31. 14 divided by 31 is 0.451612, around to thousands, tens, hundreds, thousands. Is that 5 or more? Yeah, that's a 6. So that's about 0.452. And then the next one is 26 divided by 31. So 26 divided by 31 is 0.8387. So we round that to the nearest thousands, tens, hundreds, thousands. Is that neighbor 5 or more? Yes. So it's about 0.839. And then the last one is 31 divided by 31. Oh yeah, 31 divided by 31 is just 1. Okay, yeah, all right. Okay, so then let's see. So let's see when we plot these. And we graph these. And the thing is, I was rounding to there's thousands, right? On my graph here, I only had these up to the nearest hundred, so I have to kind of estimate. I'll have to estimate a little bit. So let's see. So when we kick this off, it's going to be 39.85, right? We're going to bound at. So this is 39.85, and that's going to be bounded at 0. Has to be anchored. Okay. And so that's 39.85 at 0. Okay, then we're at 42.85. 42.85. And then I want to plot this. So to the nearest thousands, I'm looking at about 0.065. Okay, so let's see. Yeah, but these are nearest hundreds. I don't know. We might have like if you do something like this on your computer, see how I don't know if you'll have any quite this way because this is out here to the nearest thousands, and then this is only out to the hundreds. But you see, if I look for 0.065, here I go up here, 0.06. So I remember these are like in 5 cents, 10 cents. So it's a roundabout answer here. So it's about 0.065 because these are hundreds. So I don't know if I round this off, if I go back to the hundreds on this one, this would just be like 6 pennies, right? 0.064 is about 6 cents if I round to the hundreds, right? And then when I have this to the thousands, it's 0.065. Okay, so I'm thinking of if I go ahead and put this to the nearest hundreds, I know, and I'm sorry, I know I had this to the thousands, but if I do this to the nearest hundreds, then this would be closer to 6 cents, right? Looking at the original, what it was equal to. So I think I'm going to use 6 cents, okay? Because if I use this and I say 7 cents, then I'm kind of generating a round off error because I rounded here and then I round again on top of that. I round again to the nearest hundred. So that's not really fair. I round here to the thousands and then I round here to the hundreds. So I'm thinking of leaving this at about 6 cents instead. Only because this graph, when it was generated, it wasn't generated to the thousands. This y-axis was generated to the hundreds. Okay, so the roundabout answer would be about six. I feel more comfortable saying 6 cents based on this. Okay, so sorry about that little discrepancy there. I forgot about the y-axis. These were in the hundreds place. So on your homework, if you have one like this, usually what's been happening, like on your in your book, they were terminating. Remember, they were terminating. So you may not have one that goes out. You may not have one that goes out to the thousands. See, this is hundreds, and so that's why we said this would be thousands. And if you do have one that goes out to the thousands, then when you look at your graph, they should have something that goes out also. Um, you know, with respect to that as well, thousands as well. They should reflect that. But if they don't, um, and you see that these are in hundreds, then always go to the exact and then say, oh, that's about 6 cents. Okay, so I'm at 6, and you still have to kind of estimate. See how these are? There's not one exactly 6. It jumps from 5 to 10. So you're still going to have to estimate a little bit, just like a little pinch off of that. And so I'll put 42.85, and then I'll go ahead and, like, what did we honor after all? We were saying 6 rounding to hundreds, okay? So then next is 45.85. Oh, and then also you would take your mouse and connect this here. So it has to be, that would probably get marked on the computer because it's kind of crooked. So make sure you drag it straight. But 45.85. So again, I know I don't have these to the thousands mark. So if I went around to the hundreds, I look over here and this is more like 13 cents, right? This is more like 13 cents if I use to the nearest hundreds. So because they're not, the y-axis is not noted in thousands. So let me go back to this exact and round that to nearest hundreds. Is it closer to 0.12 or 0.13? Be about 13 cents. So, and so we still have to kind of estimate 13 cents about right there. And then after 45.5, they're going to increase in 3. This is 48.85. Okay, keep forgetting to connect this. Get your mouse and connect these. So 48.85. Okay, let's see. So I would say 29 cents. Okay, and in both cases, even this one's 29 cents, but to go more accurate, go to exactly what it was. Is that closer to 29 cents or 30 cents? 29 cents, okay? And then after now we have 51.85. Okay, let's see, 51.85. Okay, so we're looking at 14 divided by 31. Okay, so you see, So since our y-axis doesn't have thousands, that's why our y-axis has like hundreds. So that's why I go back to this. And is this closer to 45 cents or 46 cents? 45 cents. Add 3 more. So we're at 54.85. So 54.85, 26 divided by 31. And this is the exact decimal. So if my y-axis had been in the thousands, I would have felt comfortable using this. But since my y-axis is in hundreds place, then I'm going to go back to the exact and ask myself, is this closer to 83 cents or 84 cents? If I round to there's hundreds, then this is neighbor is 5 or more, so add 1. This is more like 84 cents. So you just on this one, when you do your homework, if you have an example like this, you just pay attention to your y-axis. And when the computer looks, you look at your choices or you look at your y-axis and look ahead at your y-axis. 57.85, so 57.85, and then that was 1, as it should be, right? That's the requirement. Okay. And then I have a note here that, you know, for this, this is XY, right? So I do have a note here that, let's see, that the last Y coordinate equals 1 always for the, for these, for these cumulative relative frequencies, okay? So look at your picture. Where's page 40? I was looking at 41. Yeah, so I was looking at 41, page 41, and you see how this also equaled 1, and it was for the cumulative relative frequencies. Okay. All right. Okay. And I'm just looking at the title. At the top of the title, I just put relative frequency graph, but then I have in parentheses ogive a cumulative frequency polygon. Okay, that was another name for the ogive, right? Let me see if I go back to the very first page. Yeah, that I got that title from here. The very first page, the cumulative frequency graph, is called the ogive. So that's where this title came from. But I was looking for this relative frequency graph. So, but I do have cumulative. I do have here cumulative relative frequency. I just didn't put cumulative at the front there. Okay. All right. And then I think that will do it then. That covers all our pages. Okay. Okay. So um, work work on your homework and be able to finish 2.2. And this is the second. This is part 2 of this lecture. So you will be working on some of these problems then. Okay. Like this of this type. And remember, if you have questions, remember your tutoring, you have Mathworld tutoring. So if you have questions, you have Mathworld's open in the summertime. They're only open Mondays through Thursdays, but in the fall and the spring, Mathrow is open Monday through Saturdays, I believe. Yeah. So just remember, if you need help with statistics, you need to go to your virtual math role and go to a stats tutor. So they work Monday through Thursday. They're open like from 8 a.m. to 7 p.m. And then on Fridays and Saturdays, they're open. They just close earlier. On Saturdays and Fridays, I think they close at 2 o'clock, I think. I think they're open from 8 in the morning, but I think they close at 2. Um, but I think they work through the lunch hours, some of them their hours. So they're working from home, okay? And so, but they're just there waiting for students to buzz them like Zoom them, join a Zoom link and ask them questions. But that's what they get paid to do. So they don't have to create lectures like I'm creating lectures for Zoom, and I'm responsible for grading, right? And creating the tests in Canvas and those kind of things. Their only responsibility is to tutor. So if you have questions after looking at my Zoom video, and even when you're working on your homework, then your task is to zoom in with those tutors, and there's several of them. There's just not one tutor. Although Gertrude, we go by Trudy, Mrs. Hurd, although I say she's the go-to person because she's actually sat in the courses, there are other people that are assigned to teach statistics or tutor statistics. And so you would need to join them to supplement these Zoom videos. Okay. All right. So good luck with your homework. Of course, also on your homework in Connect Math, there is a little built-in tutor as well, right? And the Show Me and those little teaching tools, instructional tools that are open. So those are also available as well. Okay. But other than that, remember your math row, because that's why we have them. That's why we have them open. That's their job, is to help you supplement the instructor's notes and the instructor's Zoom videos. Okay. All right. Okay. Good luck with your homework then. Bye bye.